Hello, hello. All right. Let's see if we're running here. Okay, it seems like we're live. I have to grab one thing and then we're going to work on evaluating statistical claims. Okay, so let's see. Okay. All right. So let's see here. I'm just going to get this out there for people to see. And then we'll go from there. We're going to be working on, again, more stats, more math, just for everyone to get some practice in. Okay. And let's see. Let's see. Boom, 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 boom. Okay. All right. Let's see this here. We can do this question in 1 second. Just sending out the link to some people who asked for it, and then we'll go from there. Okay. So I hope everyone's had a good Saturday. I hope this is also fun. And then I know it can be kind of annoying to be studying for the SAT so much, but if you're taking in October, you're almost through. All right, so let's see. All right. Okay. Boom, 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 boom. Okay. I was hoping this method would work, but it doesn't seem like it's going to work. So I'm going to stop sharing my screen. Okay, and then I'm going to open up the PowerPoint again. This technical stuff, is always the most annoying part of almost anything, really. Okay, and then I'm going to do that, do this. I'm gonna share the screen. Boom. Okay. Okay. Let's just see here. Okay. So we'll be working on statistical claims, which I have done in the past. Or actually, I haven't done this one before. I've just done math, but not this specific one. Okay. And once we have that going, we will go from there, right? If you have any questions, you can let me know. You can always let me know in the comments. Hi, Axolotl. Thanks for joining. And then we will make some magic here, right? Okay, and if there's any audio issues or video issues, also let me know that, right? But I think it should be smooth. I've been doing these a while and they've been pretty smooth. Okay. So I'm going to share the screen again. A sample of fourth grade students was selected at random from certain school. The 40 students completed a survey about the morning announcements, and 32 thought the announcements were helpful. Which of the following is the largest population to which the result of the survey can be applied? The 40 students who were surveyed, all fourth grade students at the school, all students at the school, all fourth grade students in the county in which the school is located. Okay, so you want to think scientifically here, right, about how you would design a good study. So for this one, right, a sample of 40 fourth grade students at random from a certain school. So it's specifically grade 4, specifically a certain school. So those parts aren't random. So if they're not random, we sort of have to stick within the scope of that. The 40 students completed a survey about the morning announcements, and 32 thought the announcements were helpful. Which of the following is the largest population? So what's the population we can apply it to? The 40 students who were surveyed, if we were just applying it to them, that'd be a terrible sample, right? And you should usually be able to apply to more people than just the people you were doing the survey on. All fourth grade students at the school. If you did all fourth grade students at the school, that would be possible, right? Because we're studying fourth grade students at a specific school. All students at the school, that one we are going to eliminate because fourth grade students can be very different from, say, kindergartners or first grade students, right? So since we're not getting a random assortment of grades, we're getting a random assortment of students from fourth grade. We have to stick to fourth graders. All fourth grade students in the county in which the school is located. That one feels a little better than all students at the school, right? Because it's still focused on all fourth graders. But since we were only choosing students from one school, we can't exactly go with that because if it was just one school, that school could be very different from the others, right? It could be a school of, let's say, gifted and talented students, right? And they might have a different opinion than students who aren't. Or it could be a school for students who flunked out of all the other schools, although I hope fourth graders aren't flunking out. And that would be a different opinion than other schools, right? Or it could be a school by a river, and that could even change their opinion because maybe they want to stare out the window and look at the river, right? So because we're not doing a random assortment of schools, we have to focus only on the school we choose, right? Just like if you were doing a study on random people in the US, you could apply it maybe to the whole US, but you can't apply it to all nations, right? You can't say everyone believes this because it would not work, right? Let's say you did a random study in the US and you found that most people spoke English. You can't then say most people in the world speak English because in the US, English is the language and around the world it's different, right? So here, it could even be that this school has certain morning announcements that other schools wouldn't have, and that would affect what people and students thought of it, right? So we're going to go specifically all fourth grade students at the school, right? So it's a little broader than just 40, but it's not as broad as C and D. And if you have any questions on that, feel free to put them in the comments. And we're going to go on to the next one. Okay. Okay, so let's see this one here. Okay. Residents of a town were surveyed to determine whether they are satisfied with the concession stand at the local park. A random sample of 200 residents was selected. All 200 responded, and 87% said they are satisfied. Based on this information, which of the following statements must be true? Okay, so it's not can be true, it must be true, right? That's a stronger statement. So we have to be very careful about what we're saying is definitely true. Of all the town residents, 87% would say they are satisfied with the concession stand at the local park. And two, if another random sample of 200 residents were surveyed, 87% would say they are satisfied. Okay, so then one choice is neither. That would say both are wrong, A, right? The next choice is B, 1 only, C, 2 only, and then D, 1 and 2, right? So again, like before, you want to read all the answer choices, and then you want to think about which ones make sense and which ones don't make sense, okay? So when you're doing a random sample, right, what can you extrapolate from it, right? So of all the town residents, 87% would say they're satisfied. So that sounds pretty good. But the issue is that when you do a sample, you can't have perfect certainty. You can have a range, and that's where margin of error develops, right? So if you do a big sample and you get like 88%, you might think, oh, maybe it's between 86 and 90%, and you have a 2% margin of error, right? But you can't say for sure that 88% is the definite one. So this is saying it must be true that 87% would say they're satisfied with a concession stand. That does not work, right? Because it's not 87% who would say this. It's probably close to 87%. That could be true and that might work, but saying exactly 87%, so goodbye to one, goodbye to B, goodbye to D. Now, what about two? If another random sample of 200 residents were surveyed, 87% would say they are satisfied. This is similar to one, but actually it's even worse than one because there's a more variety between samples than there is between a large sample and the overall population because the samples could be totally different types of people, even if you're trying to do random, right? There's a higher chance that they're different from each other than either are from the big group. So, what this means, excuse me, thank you. Okay. That would mean that you don't have, again, 87% to say they're satisfied. That can't be, that's not necessarily true. So it's not two either. So goodbye to C, and we are left with A, neither. Neither is true, right? You need to have a pretty high level of confidence to say certain things are true. And this one doesn't work like that. All right. So if you have questions on this, let me know. And now we can go on to the next one. A survey was conducted using a sample of history professors selected at random from the California State Universities. Those are great schools. The professors surveyed were asked to name the publisher of their current text. What is the largest population to which the results of the survey can be generalized? All professors in the United States, all history professors in the United States, all history professors at all California State Universities, all professors at all California State Universities. Okay. So for this one, right, it's very similar to the first one. That's the nice thing about these, and this is why I wanted to do them. Because once you know the pattern, they become very straightforward. Even though there aren't that many example problems to do yet, once you know it, you can do it. So all professors in the United States, all history professors. Okay, so we know the sample comes from history professors. So just like when we got samples about fourth graders, meant that we could only extrapolate on fourth graders. Here, when we're getting a sample on history professors, that means we can only get extrapolate on history professors. So it's not going to be all professors here, and it's not going to be all professors there, right? It has to be about history professors. And then they're selected from California State Universities. So just like with the fourth graders from a certain school, we could only extrapolate on fourth graders at that certain school. Here, we can only extrapolate on history professors from the California State Universities. So it's not all history professors in the United States. It is C. All history professors at all California State Universities. Okay. Okay. I hope that is, and that makes sense, right? History professors have different textbooks than math professors, so they might have different publishers. And California State Universities might have a deal with certain publishers, and that maybe the University of Georgia doesn't have, right? Or the state universities in New York don't have. So it's about nailing it down, which is C. All history professors at all California State Universities, right? So that's a nice in-between point. All right, and whenever I'm looking down, it's just to make sure there's not new comments or anything. Mhm. Okay, let's see this one. And if you have any questions on any other type of question, always feel free to ask it, right? I'm always happy to help with any SAT or any school related topic, really. Although the focus has been on SAT, I'm happy to do a bunch of different things. The member of a city council wanted to assess the opinions of all city residents about converting an open field into a dog park. Okay. The council surveyed a sample of 500 city residents who own dogs. The survey showed that the majority of those sampled were in favor of a dog park. Which of the following is true about the city council's survey? Okay. So it shows that the majority of city residents are in favor of the dog park. The survey sample should have included more residents who are dog owners. The survey sample should have consisted entirely of residents who do not own dogs. The survey sample is biased because it is not representative of all city residents. Okay, let's see, right? They surveyed a sample of 500 city residents who own dogs. So this is where we know whether it works or not, right? So 500 city residents who own dogs. Which of the following is true about the city council's survey? Shows the majority. Okay. So can it show us this, right? Is this a good sample? I would say the sample is not a great sample because it's only showing people who own dogs, right? And it's not a city that everyone owns dogs in. So it shouldn't be A. The survey sample should have included more residents who are dog owners. Well, it's all dog owners, so do we really need that? The survey sample should have consisted entirely of residents who do not own dogs. Well, that sort of creates the same issue in the other direction, right? Right now, it's biased towards people who have dogs, and the other one would be biased toward people who don't have dogs. And a city's a mix of dog owners and non-dog owners, right? And then the survey sample is biased because it's not representative of all city residents. That is our answer. It's not representative because even if it's a random sample of dog owners, it's still only focused on dog owners, right? And of course, dog owners are more likely to want dog parks than non-dog owners, right? Because they're the ones who would use it. If I don't own a dog, maybe I'd be for it because I'd want people who have dogs to have a dog park and I would want dogs to have a nice life going to dog parks, but I'd probably be less likely to be interested in that than someone who actually owns the dog, right? So this was an imperfect study, so we can't make a conclusion like A, and then D is a very general answer, but it's the truth, right? That they are not representative of all city residents. Okay. And now we'll move on to the next question. A trivia tournament organizer wanted to study the relationship between the number of points a team scores in a trivia round and the number of hours that a team practices each week. For the study, organizers selected 55 teams at random from all trivia teams in a certain tournament. The table below, the table displays the information for the 40 teams in the sample that practice for at least 3 hours per week. Okay. Which of the following is the largest population to which the results of the study can be generalized? A, all trivia teams in the tournament that scored 14 or more points in the round. B, the 55 trivia teams in the sample. C, the 40 trivia teams in the sample that practiced for at least 3 hours per week. And D, all trivia teams in the tournament. Okay. So this is similar, right, to the one we had about professors and fourth graders. Okay. So which of the following is the largest population to which the results of the study can be generalized? Okay. So to which the results of the study can be generalized. So the table displays they selected 55 teams at random from all trivia teams in a certain tournament. Okay, so it's a certain tournament, just like it was a certain school And just like it was the California State Universities, the table displays the information for the 40 teams in the sample that practice for at least 3 hours per week. Okay, 3 hours per week is going to be, okay, for 40 teams. Okay, so that's another limitation, right? Certain tournament and 3 hours per week. All trivia teams in the tournament scored 14 or more points in the round. Well, there's people here that have scored less, so I think it could extend. The 55 trivia teams in the sample, the 40 trivia teams in the sample that practice for at least 3 hours per week. Okay, all trivia teams in the tournament. Okay. Table displays. Okay. So the organizer selected 55 teams at random, right? And this table is just showing us the people who practice for more than 3 hours, but they selected 55 teams. We're not even getting the full 55. So there's 15 teams we're not seeing here. And they're probably the ones that practice less than 3 hours, right? Okay, so then that means that we can actually extrapolate beyond what I was saying, right? It isn't just the 3 hours or more, because we're actually talking about all teams. We're just seeing this. So this table is just being used to make it confusing. So that means we're going to go with all trivia teams in the tournament, which is D. Okay. Again, if you have questions on this, why it works like that, or how we could do it better, let me know in the comments and we will work on that. Okay. A psychologist designed and conducted a study to determine whether playing a certain educational game increases the school students' accuracy in adding fractions. For the study, the psychologist chose a random sample of 35 students from all the students at one of the middle schools in a large city. The psychologist found that the students who played the game showed significant improvement in accuracy when adding fractions. What is the largest group to which the results of the study can be generalized? Okay. So it's probably not A, because it's usually not just the sample there. So it can usually be bigger than that. But we're going to keep it in until we read all the answer choices, right? All students at the school, all middle school students in the city, all students in the city. Okay. So for the study, they chose 35. The random sample was 35 students from all the students at one of the middle schools. So the school is not random, but the students chosen within the school is random, right? So that means that we're going to be dealing with it can't be all middle school students in the city, and it can't be all students in the city because we're just focused on one specific middle school. So then we're between A, the 35 students in the sample, and B, all students at the school. Since it was a random sample, we should be able to extrapolate to the middle school from which the random sample was taken. And that means it's going to be B, all students at the school. Okay. If you have questions on that one, let me know in the comments. But again, you're limited by the fact that it's one middle school, but since it's a random sample at that school, you can extrapolate on the entire school, right? Okay, but it said fifth graders, then we could only do it just on fifth graders. Okay. Now let's go on to the next one. A polling agency recently surveyed 1,000 adults who were selected at random from a large city and asked each of the adults, are you satisfied with the quality of air in the city? Of those surveyed, 78% responded that they are satisfied with the quality of the air in the city. Based on the results of the survey, which of the following statements must be true? Of all the adults in the city, 78% are satisfied with the quality of the air. If another 1,000 adults selected at random from the city were surveyed, 78% would report they were satisfied with the quality of the air in the city. If 1,000 adults selected at random from a city surveyed, 78% would report they were satisfied with the quality of the air in the city. So that's from a different city, right? And this is from the same city. So that's the difference between these two choices. Okay. So I'm going to let you think about it. If you get an answer, feel free to put it in the comments. I love when people, put their answer in and participate on these. That's sort of why we do them live. Let's see here. Okay. So which of these can we take, right? This is very similar to the one we did earlier where there was like 87% of people said something. So of all the adults in the city, 78% are satisfied with the quality of the air in the city. If another 1,000 adults selected at random from the city were surveyed, 78% of them would report they were satisfied with the quality of the air in the city. Okay. So again, this is the issue, right? 1,000 adults were surveyed at random from a large city. That sounds great. And 78% said this, but there's a margin of error, right? We can't say for certain that if we took the whole city, we would know exactly 78%, right? Could be there's a margin of error of 0.1%, but that still makes it not be 78%. It could be, that would mean you're between 77.9 and 78.1. The only way something like A would be true is if the sample were the size of the population, right? So 1 is not true. If another 1,000 adults selected at random from the city were surveyed, again, this one doesn't work, right? A different sample, maybe there's a good chance that they'll be close to it, but exactly 78%, that doesn't have to be true, right? It's not must be true. It could be true, but probably not exactly 78%. And then the last one here, if 1,000 adults were selected at random from a different city, were surveyed, 78% of them report they were satisfied with the quality of air in the city. Okay. So again, this one is going to give us what? It's gonna give us 1,000. This is even more far off because it's not even the same city we were working in, right? So again, that one also doesn't work. So 2 didn't work. 1 and 2 didn't work. 1 and 3 didn't work. A has to be it, right? None. We can make no assumptions about this. Okay. Now we'll do this one here. A market researcher selected a random group of people from a random group of people who indicated that they liked a certain book. The 200 people were shown a movie based on the book and then asked whether they liked or disliked the movie. Of those surveyed, 95% said they disliked the movie. Which of the following inferences can appropriately be drawn from this survey result? Okay. So a market researcher selected 200 random people from a group of people who indicated they liked a certain movie. Okay. Hmm. They liked a certain who indicated they liked a certain book. The 200 people who were shown a movie based on the book and then asked whether they liked or disliked the movie. Of those surveyed, 95% said they disliked the movie. So the people liked the book, disliked the movie. Which of the following can you draw, right? At least 95% of people who go see movies will dislike this movie. Okay. At least 95% of people who read books will dislike this movie. Most people who dislike this book will like this movie. Most people who like this book will dislike this movie. So you want to be careful about what conclusion you're drawing, right? So it's not about at least 95% of people who go see movies. First of all, the at least I don't think really works at all. But even if it did, the sample we're taking from is from people who like a specific book, right? Not people who go see movies. So we can't know anything about people who go see movies. The only things we can know about are people who have read this book and liked it. At least 95% of people who read books will dislike this book movie. Again, it's not about people who read books in general. Again, the at least doesn't make sense. And it's not about disliking this movie. It's not about, yeah, so that's also not accurate. It's too broad. Most people who dislike this book will like this movie. And it's not about people who dislike the book. It's about people who like the book, right? So most people who like this book will dislike this movie. So again, D works. D is the right answer. For a lot of reasons, it's a good answer because it's focused on the right group we want. Most people who like this book. It's focused on the right opinion that they give, right? Who will dislike this movie. And then it's also not saying exactly 95% of people who like this book will dislike this movie. It's just saying most, right? And maybe they could even be more specific, but they can't say specifically exactly 95%, right? It's just a more general situation, right? So if you have questions on this, let me know. And again, if you have questions on anything, let me know. And I also have videos already on other topics you could go see. I've done live streams before that are still up. Okay. Near the end of a US cable news show, the host invited viewers to respond to a poll on the show's website that asked, do you support the new federal policy discussed during the show? At the end of the show, the host reported that 28% responded yes, and 70% responded no. Which of the following best explains why the results are unlikely to represent the sentiment of the population of the United States? So this time they tell us already that it's not a good sample, right? There's a reason that it doesn't totally fit. Why this unlikely to represent, okay? So near the end of a US cable news show, the host invited viewers to respond to a poll on the show's website. The percentages do not add up to 100. So any possible conclusions? That's not true exactly because it could be this 2% are undecided and we're just missing that part, or it could be some weird rounding error things. So I would say it's not because of A, but let's look at the other choices. Those who responded to the poll were not a random sample of the population of the United States. That's usually a pretty good reason why it wouldn't work, right? If you're not a random sample, something's going up. There were not 50% yes responses and 50% no responses. Again, there's no reason why that would invalidate it, right? There's a lot of things that we don't have 50-50 split on that could still be true. And then the show did not allow enough viewers to respond to the poll. I mean, maybe that's a case, but I think that's less strong than the one about the sample being different. And why is a sample a bad sample, right? I'll tell you why. Because it's a specific news cable show, right? If everyone in the US watched this cable show, maybe it'd be better. But even then, it wouldn't be a total fit because not everyone's answering. And maybe there's a difference between the type of person who goes on the website out of their way to answer a question and those who say, nah, I'm not going to answer it, right? So even then, that would be an issue. But this is a huge issue, right? If someone is watching, Fox News, that's a very different opinion from MSNBC, very different from CNN, different from ABC News, different from local news, right? And if you're watching, yeah, so it's just, we know this already that there's different types of populations that watch different types of shows. So we can't say that this is true. And why can't we say it's true? Because they're not a random sample, right? B. Okay. If you have questions on that, you know what to do. All right, now let's go on to the next one. All right. To determine the mean number of children per household in a community, Tabitha surveyed 20 families at a playground. For the 20 families surveyed, the mean number of children per household was 2.4. Which of the following statements must be true? Okay. So she surveyed 20 families at a playground. Okay. For the 20 families per household was 2.4. Which of the statements must be true? The mean number of children per household in the community is 2.4. Okay. And again, it must be true. So that's a strong statement you'd be making. A determination about the mean number of children per household in the community should not be made because the sample size is too small. Okay, 20 is not huge, but maybe. C, the sampling method is flawed and may produce a biased estimate of the mean number of children per household in the community. Okay, and D, the sampling method is not flawed. It is likely to produce an unbiased estimate. Okay, so D could sometimes work if the sampling method were not flawed. So that's the question, right? Is it flawed or not? I would eliminate A because again, that's a very precise number. It would have said is around 2.4, then maybe it had a chance. But saying it is 2.4, I'm not liking that. Okay, B because it's too small, possibly, right? The sampling method is flawed and may produce. Okay. So what is it, right? Is it flawed or is it not flawed? And if it's flawed, is it because the sampling method is flawed or is it because the sample size is too small? Okay, 20 families is kind of small, but that's not the issue. The issue is that she did the survey at families at a playground. And then she's asking about number of children per household. Okay, who goes to playgrounds? Families. Who goes to playgrounds? Maybe especially families with multiple kids. So maybe this is higher than you would get if you just did a whole population sample, right? This is biased in a way. It's not biased in the ways we thought about, but it's tilted in one way, right? Let's say you went to a college and asked students how many kids you have there, right? The sample would be much lower because college kids, for the most part, don't have children. So again, it would have to have been her doing a sample of all families in the community. Not that she has to do all families, but she has to do a sample that's randomly selected from all families, right? And that would be C. All right, we'll do another one. Then we might do a couple more. We'll probably just do 45 minutes today. Each face of a fair 14-sided die is labeled with a number from 1 through 14, with a different number appearing on each face if the die is rolled one time. What is the probability of rolling a 2? Okay, so this is different now. This is not evaluating statistical claims. This is just about probability. It's labeled with a number with a different number appearing on each face. If the die is rolled one time, what is the probability of rolling a 2? Okay, so if you're going to roll a 2, and you have a 14-sided die labeled with a different number on each face, right? So there's 14 total options, and there's only 1, 2, and you want to get the 2. So it's going to be, you just have 1, so it's going to be A, 1/14th, right? So that one's pretty straightforward. Now I'm going to stop sharing my screen, and we're going to keep going once I have the document up. Okay. Next week, I think I'll be doing some verbal work, okay, on reading and writing. Let's see here. Okay. Okay. To make this a little smaller. Okay. So the same 20 contestants on each of 3 days answered 5 questions in order to win a prize. Each contestant received 1 point for each correct answer. The number of contestants receiving a given score on each day is shown in the table above. No contestant received the same score on 2 different days. If a contestant is selected at random, what is the probability that the selected contestant received a score of 5 on day 2 or day 3 given that the contestant received a score of 5 on one of the 3 days. Okay. So how many people received a score of 5 on day 2 or day 3, right? So the score of 5 out of 5 on day 2 or day 3, we have 2 people plus, or means it's going to be, you add them together, so you have 5 people there. Given that they received a score of 5 on one of the 3 days, so that's basically on any of the 3 days. So we have 7 total days there, right? So it's going to be 5 out of 7 because we're given that it's the contestant received a score of 5 on one. So we're not doing the whole sample. If it just said day 2 out of day 3, we would do 5 out of 60. But since we're given that it's only a specific part of the sample, we go with that one. Okay. We did this one already. All right, let's try this one here. Okay. The table above shows information about 14 cars listed for sale on an auto dealer's website. If one of the cars listed for sale is selected at random, what is the probability that the car listed for sale selected will be a hybrid car priced at no more than $25,000? Okay. So priced at no more, right? So the car, if one of the cars is selected at random, what is the probability that the car selected will be a hybrid car? Okay. Priced at no more than $25,000. So we're dealing with hybrid cars, no more than 25,000. So that's 2. And the total is just selected at random, right? Cars listed for sale, which is all of them. So it's going to be 2 out of 14, which is just, when you divide by 2, 1 out of 7A. Okay. All right, so that one is pretty straightforward. A lot of these questions, right, the math itself is not that complicated. It's just about reading the question carefully and knowing what to look for and what to not focus on. The table shows the number of different colors of marbles in a bag. If a marble is chosen at random from the bag, what is the probability that the marble will be blue? Okay, so there's 8 blue, oh no, 10 blue marbles. See, I'm already messing up there. Okay, and there's a total of 40 blue, and we're choosing randomly from the bag. So it's going to be 10 out of 40, which is D. Often they'll simplify it. This one's not simplified. If we had simplified right, we would have gotten 1 out of 4. All right, if you have questions on that, I gotta find a new phrase. I should just say ask questions or something. All right, on Tuesday, a local gas station had 135 customers. Table above summarizes whether or not the customers on Tuesday purchased gasoline, a beverage, both, or neither. Based on the data in the table, what is the probability that a gas station customer selected at random on that day did not purchase gasoline? Okay, so for this one, right, based on what is the probability that a gas station customer selected at random? So this is 135 customers, right? Did not purchase gasoline. Gasoline not purchased, 50 people, 135. So that is going to be 50 out of 135. If we look at our answers, right, we have 15 out of 50. Doesn't do much for us. 15 out of 40 doesn't do much for us. 35 out of 50 doesn't do much for us. but 50 out of 135, right? Because was probably the gas station customer selected at random. So that's just all gas station customers here. Did not purchase gasoline. Did not purchase. Gasoline not purchased, right? So it's going to be 50 out of 35. Okay. Now we will go to the next one. The data on the coat color and eye color for 48 Himalayan kittens available for adoption were collected and summarized in the table above. What fraction of the chocolate-colored kittens has deep blue eyes? Okay, so one thing I want you to notice is I always read the question before I look at the chart. And when I even look at the chart, I just focus on what I need to know. So what do I need to know here? I'm looking for what fraction of the chocolate-colored kittens has deep blue eyes. So we're just focused on chocolate colored, right? I looked at this cream tortoiseshell, and then I see that there's also chocolate. So we're not focused on cream tortoiseshell. Buy cream tortoiseshell. You led a good life. We are focused on chocolate, which is a total of 16. So out of these 16, how many had deep blue eyes? Look at that, 12, right? So that is going to be 12 out of 16. Again, D. And I'm noticing, right, that on these, a lot of these, they don't simplify it for you. So you should look at your answers before you simplify to see if you need to or not. If you do 12 out of 16 and you see that it's not there, then simplify it and it's going to become 3 out of 4 and then look for that, right? But a lot of times they don't do that. So why should you? Why add steps that are taking you away from the answer? You have better things to do with your time and your brain. Okay. Let's see this one here. Okay, does it all fit? Yep. The table above shows the number of students from 2 different high schools who completed summer internships in each of the 5 years. Okay. No student attended both schools. Of the students who completed a summer internship in 2010, which of the following represents the fraction of students who were from Valley High School? Okay, so this is interesting. This is more specific, right? Of the students who completed a summer internship in 2010. So we are focused, guess what? By 2011, by 2012, goodbye 2009. Nice knowing you, 2008. We're just focused on 2010. Which of the following represents the fraction of students who were from Valley High School? Valley is 65. The total was 140. So look, 65 over 140. And well, you know it. If we look at our answer choices, 10 out of 140, 65 out of 140, 75 out of 140, and 65 out of 75. We are going with B, 65 out of 140. We didn't have to do division. We didn't have to do addition. We didn't have to do subtraction. And we sure as hell didn't have to do multiplication. We just had to look at the chart and make fractions from it, right? That's a very lovely strategy. So I don't have to simplify. You don't have to simplify. And that makes our life simpler. A total of 25 men registered for singing lessons. The frequency table shows how many of these singers have certain voice types. If one of these singers is selected at random, what is the probability that he is a baritone? So we are choosing from all of them. Look at the answer choices this time, not fractions, they're decimals, 0.1, 0.4, 0.6, 0.7. So that means we're going to make a fraction and turn it into a decimal. So we're looking for baritones, which is 10, out of the total, which is going to be 4 plus 6 plus 10, oops, plus 10 plus 5, and that gets us 10 over 25, which gets us 0.4. And that is choice B. If you didn't know 10 out of 25 exactly, you'd still get it because you would know it's bigger than this. It's less than half. So only B makes sense. Okay. All right. Now we'll go on to the next question. A survey taken by 1,000 students at a school asked whether they played school sports. The table below summarizes all 1,000 responses from the students surveyed. How many of the males surveyed responded that they do not play a sport, a school sport? So, of the males surveyed, right, 312. So there's 1,000 students total. Women, females, right, are going to be 220 plus 216. So they make up 436. Males, men, right? M equals 1,000 minus 436, which is 564. Okay. 312 of them play a school sport. How many males respond that they do not play? So to find that, we're going to do M no play, right? Is going to be 564 minus 312, which gets us 252. Okay, so out of the 564, 252 did not play. It's not asking for any proportion. It's just asking for how many. And that is B. Okay. Now let's go to the next one here. Okay, this one is a good one, if I remember correctly. Human blood can be classified into 4 common blood types: A, B, and O. It is also characterized by the presence plus or absence minus of the rhesus factor. The table above shows the distribution of blood type and rhesus factor for a group of people. If one of these people who is rhesus negative is chosen at random, the probability that the person has a blood type B is 1/9. What is the value of X? Okay. So here we're just focused on what? What are we focused on? Sebastian, I don't know. What are we focused on? Thanks for asking. So the probability, it's rhesus negative people, right? So the rhesus negative people here, we have 7, 2, that's 9. This is 10. The total for them is 10 plus X, right? What is the value of X? Okay, so B is 2, so it's going to be 10 plus X. 2 over 10 plus X equals 1/9. Okay. And then we just solve from there. We're going to cross multiply. All right. And then we're going to solve. So that's going to be 2 times 9 is going to be 18 equals 10 plus X times 1 is just 10 plus X. And then we subtract 10. We subtract 10. X equals 8. Okay, and that is the answer. And X is not the number of people with B, right? It's the number of people with O. So it is 8. I think sometimes people do this one and think they're doing just for the 2, and that throws them off. Okay. If one of these states parks, the table below shows the number of state parks in a certain state that contain camping facilities and bicycle paths. If one of these state parks is selected at random, what is the probability that it has camping facilities but does not have bicycle paths? Okay. So we're just doing all the state parks here, right? So let's find the total of them. Right, so the total is going to be 25 here, 12 here. We get 37. That it has camping facilities, okay? So it's 20 and 5, but does not have bicycle paths, does not have bicycle paths. So the ones who have camping but not bicycle paths is just the 5. So we're going to do 5 out of 37, which is A, right? So here we did some addition, right? Just like in the above one, we did some addition and multiplication and subtraction. So these aren't all like not possible to do, or not all these require no math like that, but it's good to be able to do them. So then it's going to eliminate for us B, C, and D, and we are just left with, that's right, A. Okay. Let's try the next one. In a bag, there are 7 red, 4 white, 33 blue, and 33 yellow cubes. If one of these cubes is selected at random, what is the probability of selecting a cube that is neither blue nor yellow? Okay. If you have any ideas, let me know. Okay. 4 white, 33 blue. What is the probability of selecting a cube that is neither blue nor yellow? So there are 66 that are blue and yellow, and there's 11 that are neither blue and yellow, right? How did I get 11? I just did 7 plus 4, and that gets me 11 out of the total, right? So it's 11 plus 66 on the bottom, which is going to become 77. So we're going to get 11 over 77, and that gets us, does anyone know? What does that get us? 11 and 77. What goes into both of them, right? 11. So we can divide them both by 11 and get 1/7. D. Okay, good, good, good. One last one, and then we are set for the day. Table gives the distribution of votes for a new school mascot and grade level 80 for 80 students. If one of these students is selected at random, what is probably selecting a student whose vote for the new mascot was for a lion? Okay. So here it's just one of these students, right? It's the entire broad canvas of students selected at random. It has nothing to do with their grade level, has nothing to do with their choice. It's just that's the total here is 80, right? You usually find it in the bottom right. Sometimes they won't have the totals and you have to add them up, but they were nice enough to have that for us. So the total here is 80. And how many of those selected lion total, right? And there's no limitation of that grade, so it's just the total of the lions, 20. Okay, and then if we look at the answer choices, this time we don't have 20 over 80, so it must be simplified. This should be an automatic one. 20 over 80 equals 1/4, and that is C. All right, we're gonna stop here for today. I hope you all enjoyed another lesson, and I